Hi, I am Rick Bonney, Director Emeritus of the Public Engagement and Science Program at the Cornell Lab of Ornithology. This presentation is part of a 10-module training program on developing and implementing citizen science projects for which scientists collaborate with members of the public to address real-world problems. The goal for this program is to introduce fundamental concepts of citizen science in U.S. federal land management agencies, which often use citizen science to manage resources and to engage the public in agency missions. This program was developed by several partners, including staff from the U.S. Forest Service, the National Park Service, the U.S. Fish and Wildlife Service, the Bureau of Land Management, and Schoodic Institute at Acadia National Park. This is the 10th module in our 10-module series. Module 9 discussed how to make your project results known to the participants who generated the information, as well as others who use the information for a variety of purposes. This presentation is on evaluating success of your project for achieving scientific and resource management objectives for parks, forests, grasslands, refuges, or similar lands and waters. It fits within our 10-part series here. 3 takeaways for this module are: first, that evaluation is performed to determine whether your project is successful, and if not, why not. Second, for best results, evaluation starts in the project design phase with the development of goals and measurable and actionable objectives. And third, evaluations seek to measure outputs and outcomes. Evaluation is actually a pretty simple concept. The idea is to find out if your project is successful. Did it meet its goals and accomplish what you hoped that it would? If so, great. What ideas and tips can you pass on to other project leaders so that their projects will be successful as well? If your project did not meet its goals, why not? How can you modify it to make it successful? Of course, to determine whether a project has met its goals, you need to have previously determined what those goals are. If you identify goals and objectives early in the project development process, you can see whether they are being achieved by compiling information about your project's participants and findings as the project unfolds. At its end, you should have solid evidence for project success as well as information about opportunities for project improvement. Most evaluations seek to document project outputs and project outcomes. Outputs are the direct products or services of project activities and typically are easy to quantify. The number of training workshops that staff deliver, the number of web pages that a project develops, the number of individuals who participate in a project, and the number of data points that participants submit are all outputs. These are important to measure, but in and of themselves do not constitute project success. For example, a project may recruit numerous participants who submit large quantities of data, but if the data are not usable for their intended purpose, then the project has been only partly successful. In contrast, outcomes are things that happen as a result of project activities and outputs. Although more difficult to measure than outputs, outcomes are true measures of a project's success. Scientific outcomes include publications, increased understanding of scientific concepts, management or policy decisions, and data products such as data visualizations or requests for data. For example, a scientific outcome could be a new understanding of the speed and depth of the spread of an invasive species on a refuge. Participant outcomes also are possible. In fact, they are a main goal for some citizen science projects. Participant outcomes may include changes in knowledge or understanding of a concept or idea, changes in attitudes towards science or in behaviors related to science, increased scientific engagement, or an increase in scientific skills. Most current citizen science projects have not conducted formal evaluations, and reports and publications documenting the success or failures of citizen science projects are few and far between. The formal evaluations that have been conducted typically focus on audience or learning outcomes. This is because grants to develop projects focused on learning, such as those awarded by the National Science Foundation, usually include funding for evaluation, whereas grants to develop projects focused on scientific outcomes typically do not. As a result, most current guidelines for citizen science project evaluation focus on measuring participant outcomes. However, at its core, citizen science is science. Therefore, measures of science or management outcomes that result from projects that do not involve volunteers also are relevant to citizen science projects. Evaluation can be a highly formal and complex process involving trained evaluators, but it doesn't need to be. Project evaluation is intertwined with project development, and for best results, evaluation starts in the project design phase with the development of goals and measurable and actionable objectives. Project evaluations often are considered in three types or phases: front-end, formative, and summative. In practice, these types of evaluations can overlap, but each has a distinct function. Front-end evaluation takes place at the beginning of a project or even before a project starts and focuses on gathering background or baseline information about potential project participants, cultural context, resource policy or management strategies, and data needs. Front-end research may be thought of as audience or market research. Formative evaluation, also known as implementation or process evaluation, takes place during project development and execution to examine whether the plan for project design and implementation is being followed. It also determines whether the project is functioning as desired. Formative evaluation thus provides direction for improving project operation and highlights strengths and weaknesses. We'll get to summative evaluation in a few minutes. This series of presentations and the associated toolkit cover the steps or phases of project design and delivery. Formative evaluation should check to see that each has been done by answering the following questions. From Module 3 on Goals and Objectives, does the project have a clearly defined goal or goals? Will the goals influence conservation or management outcomes? Are the goals supported by clearly defined objectives? Are the goals measurable? From Module 4 on Project Team and Definition of Audience, does the team include scientists, technologists, and educators, communicators? Do project staff have adequate training? Are all team roles filled by staff or partners? Has the audience been clearly defined, and have steps been taken to understand audience needs, concerns, and aspirations? From Module 5 on Stakeholders and Partners, have key stakeholders been included in project development and implementation? Are needed project partners identified and engaged in the project? From Module 6 on Data Needs and Project Protocols, does the project have a conceptual design? Have data needs been adequately assessed? Are sampling protocols well designed to collect the needed data? Is the sampling design easy for volunteers to follow? Have the protocols been tested by volunteers? Is the data entry method easy to use? Are methods for assuring data quality in place? Is an appropriate amount of data being collected? Are methods of downloading data simple and clear? Are data property and rules of access clear? From Module 8 on Participant Recruitment and Training, have appropriate methods been used to recruit sufficient volunteers? Have the volunteers received appropriate support, either through project resources or specific training? Have training and support materials been tested for clarity and effectiveness? From Module 9 on Data Reporting and Dissemination, does the project have a communication strategy for disseminating results to project participants? Does the project have a communication strategy for disseminating results to stakeholders? Does the project report on results on a regular basis? Are results being reported such that they can be used for management and conservation? And from Module 10, this module on evaluation, are project outcomes being assessed and measured? Some projects may want to develop a rubric to aid in formative evaluation. Resources to assist in this effort for citizen science projects are extremely limited, but one that may be helpful to developing projects is a paper published in Bioscience, a rubric to evaluate citizen science programs for long-term ecological monitoring. A simplification of that rubric is shown here. In addition to delineating steps in project development, it addresses how well each step is being carried out. Formative evaluation has been used effectively by Fish-Theory, which was described in Modules 2 and 7. During the development of the project on the Zooniverse platform, the project developers incorporated feedback from the Fish-Theory design team, Zooniverse staff, and Zooniverse beta test volunteers to refine data collection protocols, to improve volunteer training resources, and to provide mechanisms for data quality review. Adapting the project during the design stage based on this varied feedback proved critical to improving the data subsequently collected. Summative evaluation, also known as outcomes or impact evaluation, is conducted after a project is established or completed and describes project outcomes, determines a project's effectiveness, and describes project value. Findings from summative evaluation help to determine if a project has met its desired outcomes and accomplished its stated goals. In the context of agency-involved citizen science projects as we've described them, summative evaluation asks the questions: are the results of a project informing management or conservation? Are the results of a project contributing to the scientific literature, either formally or informally? Is a project contributing to participant learning and engagement if this is a desired outcome? Summative evaluations need to be tailored for specific projects, and they differ widely depending on the audience, context, and kind of outputs and outcomes they are seeking to document. Here we'll take a broad look at evaluating for both science and management outcomes and for audience learning. Another paper published in Bioscience, a science products inventory for citizen science planning and evaluation, can be helpful for summative evaluation. The authors set out to show many types of important outputs and outcomes beyond peer-reviewed scientific publications. While these are often considered the gold standard in terms of successful outcomes, peer-reviewed papers are not the goal for many citizen science projects, and even for many regular science projects. Other kinds of scientific outcomes are not only possible, but are desirable. The authors divide potential outputs and outcomes into science products and data practices. Science products are divided into written products, data products, management and policy products, and communication products. For instance, management and policy products might include regulatory actions, decision support tools, or forecasting or modeling tools. A written product resulting from a citizen science project on lampreys is mapping the distributions of Pacific and Western brook lampreys along the Oregon coast using eDNA in community science, the 2019 to 2022 report. Examples of projects that have successfully developed management and policy products are Project Tanager and the Imperial County Community Air Monitoring Project, which has produced a guidebook that covers monitor siting criteria, stakeholder engagement strategies, and technical advice on data storage and processing. Data practices are divided into findable practices, accessible practices, interoperable practices, and reusable practices. For example, accessible practices include downloadable data files, tools for data exploration, and metadata. Reusable practices include development of software or platforms or detailed data descriptions. A project that has successfully developed accessible data practices is Mountain Bird Watch. Data are publicly available through the State of Mountain Birds report, where the information is offered in 3 downloadable forms: raw data, a table of results for all 10 species and regions, and condensed data. Data also are organized into species-specific web pages with graphs and tables that show population change over time. The State of Mountain Birds homepage also links to data held at the Knowledge Network for Biocomplexity, where raw data and metadata can be downloaded. Data also are archived on the eBird platform. A project that has successfully developed reusable data practices is Engaging Angler Scientists, which developed a mobile application and database for surveying trout nests called REDS, and developed a RED survey protocol and handbook, which can be used by any group wanting to set up RED surveys. Not all of these products will be appropriate for your project, but knowing what these potential outputs and outcomes are will allow you to design for and evaluate achievements. If you wish to increase audience knowledge and understanding of an environmental issue or concern through your project, summative evaluation typically focuses on whether participants gained knowledge, improved their data skills, or changed aspects of their behavior as a result of project participation. Detailed information on how to evaluate whether such outcomes have occurred is included in the User's Guide for Evaluating Learning Outcomes from Citizen Science, a publication of the Cornell Lab of Ornithology. This guide includes information on planning, implementing, and sharing an evaluation, along with sample goals, outcomes, and indicator worksheets, a project model worksheet, data collection strategies, and much more. This guide has been used successfully by many citizen science projects to conduct evaluations, some of which have been published. Many of the strategies in this guide would be helpful in evaluating science outcomes as well as learning outcomes for citizen science projects. Evaluations can be carried out by an internal evaluator, an external evaluator, or both. There are pros and cons to all approaches. For example, internal staff who conduct evaluations are likely to have a high degree of knowledge of the culture of the organization and the subject matter, to be more accessible for ongoing dialogue and meetings, and are typically less expensive than external evaluators. However, internal evaluators may be seen as biased because they may have a vested interest in the outcome of the evaluation and also may face internal political challenges. External evaluators are generally more expensive, and maintaining regular communication with them can be challenging, but they are less prone to bias because they are not directly influenced by an evaluation's outcome. Some projects blend these approaches by having internal staff conduct evaluations under the guidance of an independent evaluator who reviews the evaluation design and assesses the validity of the findings and conclusions. This approach can maintain external expertise and impartiality along with the benefit of an internal person's first-hand project knowledge. Thank you for joining me today. The goal of this presentation has been to help you explore the broad topic of evaluating success of citizen science projects. We hope that you'll take away 3 ideas. First, that evaluation is performed to determine whether your project is successful, and if not, why not. Second, for best results, evaluation starts in the project design phase with the development of goals and measurable and actionable objectives. And third, evaluations seek to measure outputs and outcomes. This is the final module in this series. We hope that you have enjoyed learning about developing, implementing, and evaluating a citizen science project. The accompanying Citizen Science Toolkit includes resources to further guide your citizen science efforts. Have a great day.